Another day, another story. This is the map of Africa. If you look to the south, you'll see lush vegetation with lots of greenery. However, when you go north, things are different, covering multiple countries. It is the most gigantic desert globally, with miles and miles of dune formations. Altogether, the Sahara Desert covers 9 million square kilometers, meaning it will swallow Spain 18 times. However, did you know that this vast stretch of sterile sand covering a third of the African continent was covered in lush vegetation thousands of years ago? What happened to the Sahara? And what is happening to it right now? In this video, we will look at the terrifying discoveries scientists made under the Sahara Desert. The Atlantic Ocean borders the Sahara on the west, the Red Sea on the east, the Mediterranean Sea on the north, and the Sahel Savanna on the south. The enormous desert spans 11 countries: Algeria, Chad, Egypt, Libya, Mali, Mauritania, Morocco, Niger, Western Sahara, Sudan, and Tunisia. The Sahara Desert is most famous for the sand dune fields often featured in movies. The dunes can reach almost 600 feet or 183 meters high. However, they cover only about 15% of the entire desert. Other topographical features include mountains, plateaus, sand and gravel-covered plains, salt flats, basins, and depressions. The Sahara used to be a tropical area. So how did it become the harsh arid region it is today? The answer to this question takes us several thousands of years back. The Sahara has long been subject to periodic bouts of humidity and aridity. These fluctuations are caused by slight wobbles in the tilt of the Earth's orbital axis, which in turn changes the angle at which solar radiation penetrates the hemisphere. At repeated intervals throughout Earth's history, there's been more energy pouring in from the sun during the West African monsoon season. During those times, known as the African humid periods, much more rain comes down over North Africa. With more rain, the region gets more greenery, rivers, and lakes. But between 8,000 and 4,500 years ago something strange happened. The transition from humid to dry occurred far more rapidly in some areas than could be explained by the orbital precession alone, resulting in the Sahara Desert as we know it today. In his study, archaeologist David Wright tells us what happened next. As he poured the archaeological and environmental data, obtained chiefly from sediment cores and pollen records, all dated to the same period, he noticed what seemed like a pattern. Wherever the archaeological record showed the presence of pastoralists, that is, humans with the domesticated animals, there was a corresponding change in the types and variety of plants. It was as if, every time humans and the goats and cattle hopscotched across the grasslands, they had turned everything to scrub and desert in their wake. This led Wright to conclude that, by overgrazing the grasses, they were reducing the amount of atmospheric moisture. Plants give off moisture, which produces clouds and enhanced albedo. He says this may have triggered the end of the humid period more abruptly than can be explained by the orbital changes. These nomadic humans also may have used fire as a land management tool, which would have exacerbated the speed at which the desert took hold. Now, when you think of the Sahara Desert, do you imagine whales frolicking on the rolling sand dunes? While that is highly unlikely to happen since whales can't survive outside water, there is evidence that the ancestors of the modern whale once swam around right in the hot African desert. Rewind in 1902 when a team of geologists guided their camels into a valley in Egypt's western desert. Centuries of strong wind had sculpted sandstone rocks into strange shapes, and at night the moonlight was so bright, making the sand glow like gold. A nearby hill was known as the Mountain of Hell, because of the infernal summer heat, but in this arid valley lay the bones of whales. Some of the skeletons were 50 feet long, with vertebrae as thick as campfire logs. They dated back 37 million years to an era when a shallow, tropical sea covered this area and all of northern Egypt. And although the geologists didn't realize it at the time, the prehistoric specimens in the sand would offer clues to one of evolution's most nagging questions: how whales became whales. One clue found from these long-dead whales was the presence of feet. Scientists had long suspected that whales were terrestrial mammals that had eased into the ocean over millions of years, gradually losing their four legs. Proof of this is that modern whales have vestigial hind leg bones. But little in the fossil record illustrated the transition until paleontologists began excavating hundreds of whale fossils buried at Wadi Hittin, and finding legs and knees. Older specimens of footed whales have since been identified, but Wadi Hittins are unparalleled in their numbers and state of preservation. The valley, about a 3-hour drive from Cairo, is now a UNESCO World Heritage Site visited by some 14,000 people each year. Paleontologists speculate the whale's landlubber ancestors were deer or pig-like scavengers living near the sea about 55 million years ago. They started spending more time in the water, first eating dead fish along the shore and then chasing prey in the shallows and then wading deeper. As they did, some of them evolved traits that facilitated hunting in water over time. Since they no longer had to bear their total body weight at sea, they got bigger, their backbones elongating and their rib cages broadening. Most of the fossils in the valley belong to two types. Basilosaurus was a giant with an almost eel-like body, and the more petite but heavily muscled Dorodon looked more like a modern whale, at least until its mouth opened to reveal a jaw lined with serrated daggers instead of peg-like teeth. Interestingly, the fossils of more than 75 whales have been found in the middle of the Atacama Desert in Chile. How they ended up there has been a subject of debate among scientists. Now, have you heard about the lost city of Atlantis? You'll be shocked by how this famed city is connected to the next discovery in the Sahara Desert. This takes us to the Eye of the Sahara, also known as the Richard Structure, or the Guelber Richat. It is a geological formation in the Sahara Desert that resembles an enormous bull's eye. The formation stretches across a 40 kilometers wide region of the desert in Mauritania. For centuries, only a few local nomadic tribes knew about the formation. It was first photographed in the 1960s by the Gemini astronauts, who used it as a landmark to track the progress of their landing sequences. Later, the Landsat satellite took additional images and provided information about the formation's size, height, and extent. Geologists have concluded that the Eye of the Sahara is a geologic dome. The formation contains rocks at least 100 million years old, some dating back to well before the appearance of life on Earth. These rocks include igneous volcanic deposits and sedimentary layers that form as the wind pushes dust and water deposits, sand, and mud. Today, geologists can find several types of igneous rock in the eye area, including kimberlite, carbonatites, black, and rhyolites. However, there is another explanation for this Eye of the Sahara. According to this, the remains of the ringed city Plato spoke of in the 4th century BC can be found in the African country of Mauritania, meaning it has been hiding in plain sight this whole time. The search for Atlantis has been ongoing since the Greek philosopher Plato first described in 350 BC as a mysterious island that seemingly just vanished. We've been looking in all the wrong places for its location, since everyone assumes it must be under the ocean somewhere, such as in the depths of the Atlantic Ocean or the Mediterranean Sea, says the host of the Bright Inside YouTube channel, known only as Jimmy. Instead, he proposes the Eye of the Sahara is the mythical city's actual location. Solon, a statement from ancient Greece, is the man who is thought to have passed on information regarding Atlantis to Plato. Jimmy says it is not only the exact size and shape. Plato said it was 23.5 kilometers across and circular, but mountains he described to the north can be seen quite clearly on satellite imagery as evidence of ancient rivers, which Plato said flowed around the city. Plato said Atlantis was destroyed in a single day and night of misfortune, and sank beneath the waves. The scientific record does show the Earth underwent significant climate upheaval around 11,500 years ago, when Atlantis is alleged to have disappeared. Jimmy also points out that satellite imagery resembles the aftermath of a tsunami unlike anyone alive today would have seen. Look at the satellite map of the Eye of the Sahara. Doesn't the entire region look like it was blasted by flowing water or a tsunami? The Sahara Desert continues to serve up mysteries, and the next one is about an object found there whose functions have not been known till today. It is the Clayton Ring, and more bafflingly, these rings were found in the most inhospitable part of the Sahara Desert in Egypt. Named after the geographer desert explorer P.A. Clayton, 1896 to 1962, Clayton rings are conical pottery cylinders open at both ends. They're always found with one or more perforated pottery discs that are always just slightly larger than the ring's smaller opening but do not fit as lids. Some were custom made by potters as set, and others were reworked from old pottery jars and sherds, like the ones on display. What made these objects so crucial that people went to the trouble to take Clayton rings far into the desert? This is a question that is yet to be answered. Hey, if you learned something new today, then give the video a like and share it with a friend, and let's hear what you think of the discoveries in the Sahara Desert in the comment section. And here are some other cool videos I think you'll enjoy. Just click to the left or right and remember to stay on the bright side of life. And in last, thanks for watching.